I need to import many Python files in order to do this project. So the first is I have to import scikit-learn. From scikit-learn.datasets, I will import datasets. So basically, I am going to generate my own dataset here. That is the dataset which is present in scikit-learn.datasets. So therefore, I have to import scikit-learn.datasets as datasets. Then from scikit-learn.model selection, I have to use train test split. So I will split my data into training and testing. Then I need linear regression from sklearn. Then from sklearn, I need metrics. I also need NumPy, Pandas, Matplotlib. From Matplotlib, I will import style and I am using a dark background. So let's run this cell to import all these Python files. Now, here I am creating a data using sklearn. So this is the same method which I use in project 2 of this section. So in project 2 of this section, we created our own data using datasets.make_regression function. So I am using this same function to generate the data. So here my number of samples are equal to 1000. Number of features is equal to 3 and all the features are informative. And here I am passing a random state is equals to 42. We know from the lecture on project 2 that if we pass random state is equals to 42 or any other value, we will get the same data points every time we run this cell or every time we create the data. So the thing is that make_regression will generate data randomly. So if we pass random_state is equals to 42 or random_state is equals to any other value, we will be able to generate the same data points every time we run this code. Now let's run this cell to generate the data. Let's see the type of data. We know the function make_regression generate the data in the form of a tuple. Here is the length of a tuple. The length of a tuple is 2 because first element in this tuple is a feature and the second element are the labels. So this is exactly the same code which we do in our project 2. So here I am extracting feature and my target label. So feature is the first element of the data. We can see that the length of data is 2 and the target are the second element. Now, the problem here is if we want to see our features, so we have created these features randomly. So we have 3 features and we have 1000 sample. So again, what we did in project 2, we are doing the same here. That is, we are transforming our data features into 3 columns, that is research, salary, and infrastructure, and we transform our label into expenditure. So basically, we are transforming our random dataset into a dataset of some organization, like a dataset of a college or a university or some research company. So my first column is research. So research is equals to the first feature. So I am extracting first feature by using this line of code and I am storing it into a research. Here is my second feature. I am storing it into a salaries. And here is my third feature and I am storing it into a infrastructure. So all these steps are same. All these steps are same, which we have already saw and we have done in our project 2. So let's run this cell. Here I am changing the value. I am setting the new range for the research, salary, and infrastructure. So I am using interpolation function, which is present in NumPy. The first input is a research, and next input is basically I am setting a new minimum and maximum value for this research feature. So the minimum value is 0 and the maximum value is 2000. So here, if I see the first column has different minimum and maximum values, that is, it has many negative and many positive value. So here we have transformed these minimum and maximum value to 0 and 2000, that is in a positive range. So let's run this cell and we can see that these research values, all these values are between 0 and 2000. In the similar way, we set the new range for the salaries and the new range is between 0 and 1500. Then we set a new range for the infrastructure and then we will set a new range for our expenditure variable or for our target variable. So here I am passing the target variable to the expenditure and here I am forming a new data set. So this is my data set. So you can see that I have transformed the random data set which I created using a function datasets.make regression into a data set of a real world example. So we have a research we have salary, we have infrastructure. These three are the features, and we have expenditure, which are our target value. And we will have to see that how expenditure depend upon these three features. So next step is to have a visual inspection. In our project 2 and project 3, we learn how to visually inspect the feature and how to see the effect of each feature on the target variable. So here I have three features. Therefore, I will generate three locations. So I will generate one row, and in one row I have three columns. So I need three locations. So the super title of this figure will be inspecting each feature. The font size is 30. The figure size is 16 by 6. So I have three locations. So at the first location, I will plot expenditure against the first feature, which is research. At the second location, I will plot expenditure against the second feature, which is salaries. And at the third location, I will plot expenditure against the infrastructure, which is third feature. Let's run this cell and to see the effect of the features. So we can see that here we are inspecting our feature. We can see that salary is highly correlated with the expenditure as compared to infrastructure and research. So we see that salary will have more influence on the output as compared to infrastructure and research. The second important feature will be infrastructure, and the last is research. So we are expecting the highest value of weight for this feature, which is a salary. So this is the advantage of doing a visual inspection, that by doing visual inspection, we will able to see the effect of feature on the target value even before applying linear regression. So here I am extracting X, that is my feature, from a new data set, which is research, salary, and infrastructure. These are my three features. Here I transform these features into the NumPy arrays. Here I am extracting my targets. Now here I am splitting my data into test and train. So I am using 20% data as a test and 80% data as a training. So I am passing the input X and Y, that is feature and label, and I get four output values, that is training data, testing data, training labels, and test labels. Let's run this cell. And here I can see the shape of my test data, since I am using 20% data as a test data. So I have total 1000 sample. So the 20% of 1000 is 200. Now the next step is to standardize the data. In order to standardize the data, I am importing standard scalar from scikit-learn.preprocessing. Here I am instantiating my standard scalar, and here I am fitting and transforming my standard scalar to xtrain. We know from previous projects, then we have to standardize the data. We need to split the data first, and then we have to write fit underscore transform in order to standardize the training component of the data. And we have to use sc.transform only in order to standardize the testing part of the data. We cannot write sc.fit. Fit is basically for training, and it is used only for the training component of a data. If we use fit underscore transform as well for the testing data, this will be called as a data leakage. Data leakage means that our model is able to see the test data during the training, and when it will be used for testing, the test data will no more be unseen data for our model. So let's run this cell to perform the standardization. Here we can see that these are our standardized values of xtrain. Now, since we have to perform a gradient descent, now the gradient descent is applying. So all these steps which we have done in this project 5 are almost the same which we did in our project 2 of this section. Now it's time to apply new step, that is to apply gradient descent. So the first step is we need to generate ones, and here we are appending the ones. By appending the one, now we can see that the size of our xtrain is 800 by 4. Previously, we had three features. Now by appending a one, we have another dimension, we have another feature. Therefore, the size is 8000 by 1 and 8000 by 4. And we can also confirm from here that if we see x underscore train here, and if we run this, we call it x underscore train x. It is x train before appending the one. When we append the one at the first column, it is x underscore train x. So we can see this is the appending ones at the first column of the feature matrix, and these are the three features. Now we have to reshape our y train, and we are calling it y underscore train y. Here we are applying the gradient descent. Now we are applying the gradient descent in the same way as we did in our project 4. So this is the equation which we have to apply. After applying this equation, we will get the rate of change of error with respect to weight. This rate of change of error with respect to weight will be known as gradient. Then we will multiply our gradient with learning rate, and then we will subtract this product from our old value of weight to get the updated value of the weight matrix. So here I have initialized the weights. We have seen this before in our project 4. So this is exactly the same code which we understood in project 4. So you can see that the first step is minus 2 over n. This is minus 2 over n. Then we are multiplying these two here. Then we are subtracting it from our labels. Then we are multiplying this bracket with the x. And then finally we are updating the weights. Let's run this cell to update the weights. And we can see that this is our weight matrix. So the first value is the value of a bias, and these three are the weights. And we can see that the second weight is of largest value. The reason is the second feature is a salary feature, and the weight associated is high. It means salary has the most influence on our target variable. And we also confirm this by the visual inspection of each feature. Now it's time to test the model. We also have our testing data as well, because we have splitted our whole data into training and testing component. So we need to append ones on our testing data. After appending ones, we call it x underscore test x. Here we are getting the predictions from the test data, and here we are evaluating our model. So we can see that this is a very good model. If you can see, the root mean square error is almost 0, exponent raised to -11 and exponent raised to -1. And we can also confirm from here that the R square value for our model is 1. So in this way, we have applied gradient descent to a multiple linear regression problem where we have three features. We see that our gradient descent is performing very well, and we get the R square value is equals to 1. Now, we want to compare the performance of this gradient descent with the least square. So in order to compare, I have instantiating the linear regression model, and it is called LR. Here I am fitting my linear regression model to my training part of a data, and here I am getting the value of a bias and the value of the weights. So we can see that we are exactly getting the same value of the bias and weights as that for the gradient descent. So in this way, we can see that the gradient descent is performing well, and the performance of gradient descent is equal to the performance of a least square method. Now here we have to test and evaluate the least square model. So we are using lr.predict to get the predictions. And after getting the predictions, again, we are calculating these three metrics. So we can see that the root mean square value is also 0 here, and the value of R square is 1. So in this way, in this project 5, we perform gradient descent on a multiple linear regression problem. We created our own data using a function make underscore regression. After creating a data using make underscore regression, we transform that data into a real world data, that is into a data of some research organization. Then we extract the features, and before extracting, we visualize and inspect the importance of each feature. We saw that salary has most influence on the expenditure. Then we extract features, we extract labels. Then we split the training and testing. We get the training and testing part. After splitting data, we standardize the data. After standardizing, we perform the gradient descent, and we get the value of the bias and value of the weights. Finally, we evaluate the model by using three metrics, that is root mean square error, mean absolute error, and R square value. Then after performing gradient descent completely, we compare the performance of gradient descent with the least square method. We observe that the performance of gradient descent is up to mark with least square method. That is, both are performing equally on this data set. So I hope you understood project 5. Thanks for listening, and I will see you in the next lecture.